Hello everyone. We have already discussed internal one paper of data science, part A and part B, and today we will discuss solution of part C, which is data pre-processing for complaint analytics. We have question number 1. Discuss accuracy, completeness, and consistency issues. Propose two more quality dimensions relevant to legal analytics. Common problems are first, accuracy, wrong values, for example, mistyped monetary loss or wrong data causes wrong triage decisions. Second is completeness, missing fields such as timestamps, victim, or accused details or evidence score. Consistency is third, conflicting information across records, for example, one record says accused absent, other says accused present for same event or inconsistent formats, dates in different formats. Two additional legal relevant quality dimensions, timeliness and provenance. So timeliness, how quickly is the complaint lodged and features extracted. Delays affect evidence availability, witness memory fades. So timeliness matters for triage. Second is provenance. Can extracted facts be tracked back to original source? EFIR, audio transcript, CCTV. Provenance is critical for audit and legal defensibility. I have question number 2. For handling missing values in extracted features, discuss approaches, ignore tuples, manual completion, constant field, mean median mode imputation, class-specific imputation by offense category, most probable value model based. So approaches for handling missing values are ignore tuple, drop rows, pros, simple, cons, biased if missingness, not MCAR, loses data. Manual completion or human in the loop. Pros, most accurate for sensitive or legal fields. Cons, expensive and slow. Constant field, sentinel. For example, fill with -1 or unknown. Pros, keep record. Model can learn missingness signal. Cons, needs model to treat. Sentinel especially may distort numeric aggregates. Then fourth, mean, median, mode imputation. So pros, simple, preserves data set size, median, robust to outliers. Cons, underestimates variance, may bias relationships. Class-specific imputation by offense category, location, or other group. Pros, more accurate than global mean if groups differ. Cons, needs reliable class labels and enough data per class. Sixth, most probable value, model-based imputation. Train a model by using KNN or regression or random forest to predict missing features using other features. Pros, often best accuracy. Cons, more complex, risk of leakage, needs cross-validation to avoid overfitting. Recommended rule of thumb for routine numeric scores, use median or classify or class-specific median. For legally important field, prefer manual check or model-based imputation with auditing. We have third question, smoothing extracted scores. Use the evidence strength list from A2. A. Smooth using bin means with bin depth 3 show steps. So first we will solve this question. So we have this evidence strength list sorted in sorted order. Now bin means smoothing, bin depth is 3, non-overlapping bins of size 3, steps and results. What we will do, we will group consecutive items in bins of 3. Bin 1 will contain first 3 elements. Then bin 2 will contain all these elements, next 3 elements. So by this we will do grouping. C. ठीक है. So here what is we are making groups, and at last only two items are left. So one bin will be basically contain two elements. In last bin we will contain only two elements. So we have written them, we have grouped them, and now we are taking mean of them. And what we will do, we will just replace each value by its bin mean. Like first three elements will be replaced by its bin mean, which is 14.6667. And with all bins and all values, we will do the same. Note, alternative is sliding window overlap of step 3 that would produce smoother transitions but more computation. Now we will solve third question B part. Suggest ways to detect outliers, rare, very high impact with low evidence. So we have IQR rule, mark points greater than Q3 plus 1.5 dot 1 QR or less than Q1 minus 1.5 into 1 QR, IQR. Simple and robust. Then we have Z score method where module of Z is greater than 3 works if near normal. Robust Z score using MAD, median absolute deviation. Use median and MAD for heavy tail data. Then we have local density methods. Isolation forest, local outlier factor detect points with anomalous neighborhoods. Domain rules flag if impact is greater typical but evidence score below threshold means business rule. For example, if impact is greater than 90th percentile and evidence is less than 25th percentile, then flag. A cross source verification, so if high impact reported but no corroborating evidence from other sources, then it is suspicious. Now we have third question C part answer. So what was the question? Question was discuss other smoothing methods like bin medians, moving averages, robust estimators. So bin medians similar to bin means but more robust to outliers. Now we have lowest locally weighted regression, non-parametric local smoothing, good for trend estimation. Moving averages, sliding window means simple temporal smoothing. Robust estimators, Uber winsorization, trimmed means or median filters. And then we have exponential smoothing, more weight to recent values, useful for time ordered streams. We have next question, question number 4. Now discuss schema integration, handling redundant entries, duplicates across EFIR and physical logs, and resolving value conflicts, for example, differing monetary laws or section labels. So our answer is what is schema integration first? So map fields from different sources, for example, EFIR JSON canonical schema using ETL, mapping rules, and type conversion. User canonical data model for the DSS. Duplicate detection, redundant entries. Use record linkage or entity resolution. Compare keys like complaint ID, date, complainant name, location, and similarity of free text, cosine or TF-IDF to identify duplicates. Apply a threshold and human review for borderline matches. Then we have resolving value conflicts, so provenance weighted merge. Prefer values from higher trust sources, CCTV greater than EFIR greater than citizen SMS. Timestamp based recency rule, take the most recent authoritative update. Aggregation with uncertainty. Store conflicting values with confidence scores rather than overwriting. Present the most probable value to the DSS and keep the rest for audit. Human in the loop adjudication. For legal fields, monetary loss section labels require manual verification if conflict exceeds threshold. Now, question number 5. Explain normalization methods for feature scaling. A. Min-max normalization. B. Z-score normalization. C. Z-score using mean absolute deviation. And D. Decimal scaling. So answer is let feature values be V over dataset with min, Vmin, max, Vmax, mean, mu and standard deviation sigma. MED equals to median of V minus median of V. Now A. Min-max normalization range from 0 to 1 in which 0 and 1 are included. So this is the formula. It preserves range and sensitive to outliers. Now Z-score normalization, which is a standard score. So centers to mean 0, unit variance, and assumes roughly Gaussian distribution or used for many algorithms. This is the formula you can see. Now Z score using mean absolute deviation, robust Z. This is the formula again. And alternatively use median instead of mean, where V dash equals to V minus median upon MAD. This is robust to outliers. Now D decimal scaling, so we have the formula V dash equals to V upon 10 to the power j, where j is nothing, just log base 10 max upon V. Move decimal point, simple but crude. When to choose min-max for bounded features 0 to 100, Z-score for algorithms needing mean free data, and robust Z or MAD when outliers present. Decimal scaling rarely used except simple display or anthropic reasons. We have question number 6. Binning case severity scores are 5 to 10, 11, 13, 15, 35, 50, 55, 72, 92, 204, and 215. Partition into A. Equal frequency bins, equal width bins, clustering based bins, for example, K-means. Also explain implications for section mapping thresholds. So first we will sort the data we are given and value of n is nothing, 12. So first we will partition on the basis of equal frequency bins. So bin A will have low values like 5, 10, 11, 13. It ranges from 5 to 13 because we have 3 bins and we have 12 data elements. So each bin can contain 4 items. So that's why 5 to 13 range come under bin A, and in bin B we can get from 15 to 55, that is 15, 35, 50 and 55, and bin C rest all left out will be present. Range is 72 to 215. Now implication. Threshold based on counts are balanced. Each bin has same number of cases but ranges are uneven. The high bin covers a very wide numeric span. Now we will partition according to equal width bin. So first we'll find range. Range is nothing, just 215 minus 5. This final value minus first value. So this is the range here, and width is equals to what? 210 upon 3 means range upon total number of bins we have. So 70. Now bin 1 will contain 5 to 75 values where 75 is not included. So there will be 9 values in bin 1 which is 5, 10, 11, 13, 15, 35, 50, 55, and 72. And bin 2 will only contain one value, which is 92, and bin 3 will only contain two values, which is 204 and 215. Now we have implication. Equal width can produce highly unbalanced bin counts when data are skewed. Thresholds may be poor for rare high severity cases. Now see clustering based bins, k-means where k equals to 3, for example. So apply k-means k equals to 3 on the scalar values typical clusters approximate. So we have cluster 1, 2 and 3, low, mid and high. So in cluster 1 we have 5 to 15 values. In cluster 2 we have 35 to 92 whose centroid is 60.8, and we have cluster 3 which have high values like 204, 215 and its centroid is 209.5. We have implication. Clusters respect natural groupings and often give more meaningful thresholds for section mapping, for example, low, medium, critical, but cluster boundaries depend on initialization and must be validated. Overall implication for section mapping thresholds: equal frequency, good when you want balanced model training sets, equal with intuitive numeric cutoffs but can fail with skewed data. Clustering, data-driven thresholds usually best for mapping severity to legal priority but needs validation and may be less interpretable. Now we have last question of part C, which is seventh question. Feature selection for section mapping. Summarize with a flow chart the technique for choosing attribute used by the DSS. Forward selection, backward selection, and then hybrid method, of course. So we will start with forward selection. Start with no features. At each step, add the feature that gives the largest improvement in model performance, accuracy or F1 for selection prediction. Now stop when adding more features does not significantly improve the score. So its pros is fast when features are many, and it is very simple. Now cons is may miss combinations that perform well only together. We have B method, backward elimination. Start with all features. At each step, remove the feature whose removal causes the smallest drop in performance. Stop when removing any more features would harm accuracy strongly. Pros: considers full model initially, good for moderate feature sets. Cons: more expensive than forward selection. Now we have C, hybrid or stepwise method summary. Start, apply forward selection, add best feature. After each addition, perform a backward check to remove any feature that has become redundant. Continue until no addition or removal improve performance. Pros: balanced and handles interactions better. Cons: still more costly than pure forward selection. So here we have final flow chart. We have to start candidate feature set. Now pre-filter optional, remove near zero variance, highly correlated, etc. Now we have to choose search strategy, forward, backward, or hybrid, whatever we want to choose. For forward, add best feature and evaluate. For backward, remove worst feature and then evaluate. And for hybrid, add best and backward remove. Now, performance improved, we will see accuracy or F1. And if it is yes, then update feature subset and repeat search. And if it is no, then stop final subset selected for DSS. And here, after update feature subset and repeat search, go back to evaluation. Then we will go back to evaluation. So I think we have completed part C solution, and here we end our internal one of data science solution discussion. So thank you.